Alright, so today we're going to be doing a polynomials tutorial problem. It's a polynomial regression, and as I've been saying, for the polynomials unit, this is the most important stuff. It's being able to actually apply what you've learned into real world problems. So the government's really clear on that this is what they really want people to know, so it's probably going to be the #1 area on the diploma, or for this section. So what I want you guys to do first is please go to the Math 30-2 section and download this sheet. It's important that you try this first rather than just watching me do it, so you can actually give it a try, struggle a bit maybe, get through it, and then afterwards look, oh yeah, maybe I should have done that, okay, that's where my errors were. If you just watch me do it, it probably won't be as meaningful. And second to that, it's going to be tough for you to see a lot of what I'm doing up here, because the numbers are going to be small. This is the only way I can think of to get this done. So A, it says, what relationship do you expect to see between the latitudes of the weather stations and the mean temperatures? So to do part A, some background here, you've got these weather stations in BC. This is the latitude. It's basically how far north it is in degrees. And then this is the average temperature for July. So when it says what relationship do you expect, it's basically getting at, do you think this thing's linear, quadratic, or cubic? Well, I would guess linear because generally the temperature is going to get cooler the further you go north, but it's not going to be rapid, it's going to be kind of constant. So it's going to constantly go down as you get further north, in that the temperature doesn't all of a sudden spike up or down. So it should be kind of a steady change, which would be a line, linear. But it wants us to plot the data to verify. So this is where all the calculator stuff comes in that you really need to know. First, you want to throw your data in your list. So you're going to hit the stat button and go to #1, which is edit. So I've got all my data in L1 and L2. From science, generally you make your manipulated variable X and your responding variable Y. So the one I'm messing with is X, and the one that's responding to those changes is the Y variable, the temperature. So I'm changing the latitude and the temperature responds. So I've got all those in L1 and L2. And from there I'm going to do a stat plot. So you go second Y equals, you go to plot 1 and you're going to turn it on. So just go over, just hit enter, and only thing you're going to change in here is from off to on. So change it from off to on, and now hit graph. Now I'm assuming most of you probably do not have a nice graph like this. You probably have a single dot that doesn't show you a thing. Why? Because you have to mess with your window for these. So here's the window I'm using. My X min is 48, because if you look on these data numbers here for the X, the lowest one on here is 48.8. So I chose 48. I chose something smaller than that. That's the minimum. For my X max, you can see it goes up to 59 somewhere. 58.4, sorry, is the biggest one. So I picked 60. It's a bit bigger, and I stopped there. My X scale is by 2, so each tick is 2. For X, or for Y, I made my minimum 10, because you can see the lowest temperature here is 11.6, so I made it a little lower than that. And then I made my maximum 22, and the biggest one on here is 20.9. Okay, so I made the biggest 22, and my scale 2, so each time it goes up by 2 on my Y scale. It's important that you can do that, because here it actually gives me something I can work with. You can see here that this, I mean, if you look at that, that's roughly a line. Like if you're doing your line of best fit from science, you should have roughly the same number of points above and below the line. That roughly looks like a line of best fit. So that works there. It does look linear. So for part A, we're pretty confident with our answer of linear. In B, it actually wants us to determine the equation. So how do you do a regression equation? And what is a regression equation? A regression equation is where the calculator takes the data values and tries to approximate them with a curve. So it's going to try and draw a line or a parabola or an S shape that models your data. Well, you can see here, we need a line. So what you want to do is, you want to go into stat and go across the calculate menu where all the good stuff is. And you're going to go down to #4, which is linreg, that's linear regression. You're going to hit enter there, okay? Because we think this is a line. So you hit enter and it gives you the equation of a line that models the data, okay? So to answer part B, our regression equation is this. And I'm just going to write it here at the top. It gives you the coefficients right there. So the equation is given to me. I'm rounding it off to the nearest hundredth, -0.64 x plus 49.73. So that's my linear regression equation. I mentioned this in class. If you want to graph that thing, you can go to y equals and you can plug it in there. But if you want it in exactly and save yourself time, a nice trick you can learn is if you go to vars now, you go down to statistics, number 5, and then you go across to EQ. Number 1 is reg EQ. For whatever reason, that copies the entire 10-digit regression equation into your calculator, which is great. So if you hit graph, boom, it's there. That's my regression equation, a line. Okay, so that's part B done. Part C says, according to your regression equation, what average temperature would you expect at a latitude of 50 degrees north, 52 degrees north? It's asking at what latitude am I going to get a temperature? So it's asking for what x, what temperature would I get for an x of 52 is basically what it's asking. If x is 52, what's the temperature? Because 52 is not on here, right? There's some ones that are close, but it's not quite on here. No problem, go to your calculator, go to trace. So go second trace again, which is calculate. And go to the value, number 1, the first one on the list. Hit enter. What you can do is you can input an x value and the calculator will tell you the y value that goes with it. So I'm going to put 52 in here. And there we go. The calculator tells me here that for 52, so I'm going to have to write over top of this unfortunately, but it says for an x of 52, the y value that goes with it is 16.6. Okay, so for part C, when x is 52, y is 16.6. So in English, if the latitude is 52 degrees, the temperature should be approximately 16.6 degrees. So the answer for C would be 16.6 degrees. Now D is similar but different. In D, it's asking me, all right, at what latitude, so what x, would you expect to get a temperature of 18 degrees? So now we're working the other way. They're giving me the y, and they're saying, all right, what's the x that goes with it? And you can see 18 degrees is not on my list for temperatures. So what you do here is, there's no value put in the y, you get the x, unfortunately. So what you have to do then, because the calculator won't do it that way, go down to y2, and in y2 we're going to graph 18, which is a flat line for 18 degrees. And if I go to the graph, you see that straight line going across? That's 18 degrees. If I can find this point where they intersect, right there, that would be the value that I'm looking for. That's where our linear regression line meets 18 degrees. That's going to give me the x I want. So to do that, you're going to go now back to the calculate menu, go down to number 5, which is intersect, hit enter on one curve, enter on the other curve, enter one more time for a guess. And the calculator is telling me now, for part D, that for an x of 49.8, I have a y of 18. So it's telling me that if the temperature is 18 degrees Celsius, the latitude is 49.8, approximately. That's the calculator's best guess. Okay? So the answer for D would be, at a latitude of about 49.8 degrees, you'd have a temperature of 18 degrees Celsius. Okay? So, in summary here, what have we done? We started with a list of data. We threw it into the calculator in L1, L2. We did a stat plot on it. We did a regression equation. We then took our regression equation and answered some questions. One by using second trace value and the other one by doing second trace intersection. These are all skills you need, but once you get a lot of the little things here, like using your calculator down, it's really not so bad. Okay? Thanks for watching. I will do another one for sinusoidals later this week. And I hope this helps you understand polynomial regressions.